Welcome to the Everstream Analytics 2021 Tropical Storm Season Outlook webinar. We will get started shortly at the top of the hour. All attendees will be muted on this call. If you have any questions, please use the chat or question toolbar. This presentation will be recorded and made available to you after the webinar. Hello and welcome to the Everstream Analytics 2021 Tropical Storm Season Outlook webinar. Everstream is a leading predictive supply chain risk analytics solution that provides actionable insights to enable greater resilience and agility. We help companies think bigger, see further, and act sooner so they can get in front of what's ahead. My name is Dana Sadiq, Senior Marketing Manager, and I will be your webinar host and Q&A moderator for today. This presentation will be recorded and made available to you tomorrow. To stay informed and access our regular updates on the tropical storm season, just subscribe to the weekly supply chain risk impact summary at everstream.ai/subscribe or visit the Weather Resource Center at everstream.ai. Allow me to set the scene. Imagine this. We made it through 2020, the most disruptive year in living memory. We've survived 30 named storms in just the Atlantic Basin alone. We've endured hundreds of millions of COVID-19 infections and non-stop series of supply chain related disruptions. Supply chain leaders may be thinking 2021 can't be as bad as last year. Well, think again. Last year, there were several storm systems that caused over $1 billion in damage. One event can actually be a true disaster. Can you really take the risk of not being prepared? Take the deep winter freeze this year in Texas, for example. It wasn't so much the event itself as to the sheer lack of preparedness and sightless situations that many businesses and communities found themselves in. So no matter how predictable the weather may seem, the intensity, timing, and impact of each storm will vary. Supply chains need to plan in advance. And that's why Everstream Analytics equips our customers with predictive visibility and agility to prepare for risky events like severe tropical storm weather. To help you prepare your supply chain for this year's tropical storm season, we've invited experts from Everstream to provide insight into the tropical weather patterns for this year so you can navigate the uncertain business environment and get in front of what's ahead. Today, our panelists will provide a comprehensive overview of what to expect this season. Topics will include a look back at last year's infamous season, the drivers that will dictate this season, a specific forecast for the global basins, and a high-level look at climate change and the impact on tropical activity. Please welcome our guests, John Davis, the Chief Meteorologist of Everstream Analytics, and Mark Russo, the Chief Science Officer at Everstream Analytics. Welcome, gentlemen. How are you guys doing today?
Good, Dana.
Thank you, Dana. Doing well.
Wonderful, wonderful. I will let you go ahead and take it away, John.
Okay, thanks, Dana. Good day, everybody. So, the purpose of this webinar, as Dana described, is to take a look at the tropical storm season in the Northern Hemisphere that we're going into right now. And there's going to be many different facets of that. So, the first thing that we're going to do is take a look back at last year. Of course, last year was a very infamous year, and last year was really a study of extremes. Some areas across the hemisphere had an extremely active season. Of course, the Atlantic Basin. Other areas had a very quiet season. And so that really sets the stage for looking at the upcoming season and talking about some of the changes as we look ahead to the 21 season here coming up. So, as we look ahead to the 21 season, we're going to focus on the basins in the Northern Hemisphere. In other words, the areas that have some kind of tropical storm risk. And so, two of them will be the focus of most of this presentation. The Atlantic Basin, of course, we'll focus on quite a bit. And then the most active basin on the planet, the West Pacific Basin, areas such as China, the Japan, and Koreas. Those are the two basins that tend to have the biggest impact on the supply chain globally. And we've certainly seen that over the last couple of years. Another very active area is actually the East Pacific Basin, off the west coast of Mexico. That is a very active area, but the bulk of those storms tend to move in a westward direction, in other words, out to sea, and most of those storms are not big disruptors within the supply chain. We'll cover a little bit of the Indian Ocean, but again, the focus of today's presentation is on the two big areas for tropical storm disruptions, the Atlantic Basin and the West Pacific Basin. So if we begin to take a look back at last year, we're going to start out looking at the Atlantic Basin. So overall here coming up within the Atlantic, it's kind of a situation that last year was extremely infamous. And if we think back to last year across the Atlantic, it was a record breaking year in so many ways. And if we look at 2020 by the numbers, here's some of the overall end results that occurred here last year. We're not going to go over every one of these, but all of the numbers in red were the record breakers all time. In other words, we had 30 named storms in the Atlantic Basin last year, an all time record. We had 7 major hurricanes last year, an all time record, and 11 of those made landfall across the US. Later in the presentation, we're going to talk about RI storms, or rapidly intensifying storms, some of the biggest disruptors out there within the supply chain. That was also a record last year. And of course, last year was the 5th consecutive year of above normal activity and the 5th consecutive season with a Cat 5 in the Atlantic Basin. I guess the one good piece of information on this list is the fact that damage and also fatalities were not record breakers. So take something a little bit positive out of last year is that damage was not in record territory and the fatalities were not at record territory. The fatalities, which last year were about 432, that is likely a relatively low estimate because there's lots of unaccounted for individuals, especially in Central America with the 2 storms that hit in November in areas of Nicaragua and into Guatemala. So again, last year was just an infamous season here out there. So if we think of last season and then we begin to compare that historically, how active was last year when we add up all the different storms for the entire season? To do that, we're going to look at ACE. So we're going to compare last year in looking at ACE, which is a measure of true risk or true tropical cyclone activity. And that just simply means accumulated cyclone energy. So in other words, taking the duration of storms and then taking the intensity of storms and adding that up through the season to get the true measure of risk out there. So when we look at ACE a year ago, last year was overall the fifth highest ACE in recorded history. And overall, here across these ranges of areas of the Atlantic basin, that overall risk here certainly was one of the highest that we've seen since 2017, and one of the higher risks that we've seen in quite some time. Of course, 2005 was the year with the highest risk overall out there, and the year with the lowest ACE was 1983. And overall, here was not the highest ACE or highest activity of all time, but certainly one of the highest, the top five, going back from 1979 to this past year overall here. So let's now turn our attention to the West Pacific, our other major basin within the supply chain. So first of all, we're going to take a look at the overall tracks across the West Pacific. This is the basin that tends to have the highest amount of activity on the globe, and typically the highest amount of disruptions out there. It seems like there's a lot of storms across the West Pacific last year. However, this was a relatively quiet year a year ago, and we did not have that many disruptions across this area. We'll talk about the reasons for that in just a bit. But overall, here, this was a relatively quiet year. Now, the southern portion of this zone certainly had more activities, areas such as Vietnam and the Philippines, than you had further north. That's where it really was quiet, in places like northern China, South Korea, and Japan. And overall, here across those areas, when you add up all the activity across the West Pacific, this is an inactive year a year ago. And the measure of activity, of course, we'll look at that in using the ACE parameter overall. So if we look at last year from a standpoint of accumulated cyclone energy, these are all the years going back to 1979, which is what we call the satellite era, to last year. Last year was the fifth lowest ACE. Think of that as the fifth lowest risk of all years going back to 1979. And it was the lowest ACE since 2010. Now, looking back historically, the highest year was 1997. The lowest year was also actually in 1983. So overall here across those areas, we had a real extreme year a year ago. The Atlantic, record-setting disruptions, whereas the West Pacific, the other big supply chain basin, it was one of the quieter years that we've seen over the last 40 plus years across those areas. So now we're going to begin to look at, well, what's changed as we look ahead to this season, and what are the main drivers that will dictate activity in the West Pacific and also the Atlantic basin as we go through this year. Mark, take it away.
Thanks, John, and good day, everybody. The combination of oceanic and atmospheric conditions around the global tropics is critical in the genesis, intensity, and frequency of tropical cyclones, both from a seasonal standpoint, but also throughout the season. In other words, here, these factors help determine whether a season will be active or inactive, which then ultimately determines the risk of supply chain disruptions. Now, ocean water temperatures help set the table for storm development, but they also fuel the energy of individual storms, including their rate of intensification. Up in the atmosphere, areas of long-term and short-term enhanced or suppressed wind shear, or different wind speeds at various levels here, that aids in the formation and strengthening and weakening of storms, or even help shape regional active and inactive areas within the basin. So, one of the primary drivers of yielding favorable or unfavorable oceanic and atmospheric conditions across much of the global tropics is the El Nino and La Nina oscillation, We're not going to go into great depth here, but again, for reference, changes in this oscillation can resonate from the Pacific Ocean into the Atlantic and Indian Oceans, causing distinct trends or patterns in tropical cyclone activity. Now, an El Nino event in the Pacific is a period of warmer than normal waters. In terms of the La Nina events, those are periods of cooler than normal waters. And again, though that oscillation drives active and inactive conditions, both in the Pacific, but also can influence the Atlantic and Indian Ocean activity. And in general, El Nino events tend to produce active conditions across the tropical Pacific, but inactive conditions across the tropical Atlantic. And then vice versa, La Nina events tend to produce inactive conditions across the tropical Pacific, especially eastern areas, but active conditions for the tropical Atlantic. So where do we stand with SSTs, or global water temperatures? And that's what this map here specifically is illustrating. And one of the key items is in the Eastern Pacific, where currently SSTs are near normal or have a little bit of a La Nina flavor, as you can see here. These blue shaded areas indicate cooler than normal water temperatures, and the red shaded areas are warmer than normal water temperatures. But for this season, we are expecting normal to very weak La Nina conditions. So that is one primary takeaway with water temperatures. Now, in the Atlantic, the situation is in some ways similar to last year. It's warmer than normal. And that is especially true currently in areas of the Gulf of Mexico and in more of the central and northern portions of the Atlantic Ocean. So the basin overall is warmer biased. As we turn to the Westpac, a bit of a more normal situation, or with some variability in SSTs across the region, as you see here on this map. And then finally, the Indian Ocean has more of a warmer bias, especially areas just offshore the Indian subcontinent, both in the Arabian Sea and the Bay of Bengal. So this is the overall base state of SSTs going into this upcoming season. Now, taking a little bit of a closer look at some of our more regional areas, one very important difference is that in the tropical Atlantic here, this year compared to last year, this year is certainly not as warm as last year. And if we look at what we call the main development region here, where African waves travel then across, primarily track across the eastern Atlantic and then head towards the Caribbean or the US, that's what we call the MDR region, where most of the activity begins to develop, actually a bit more kind of mid to late season. Early in the season, you tend to have more activity, what we call homegrown storms that typically form in the Gulf of Mexico or right off the southeastern coast of the US. Actually, these areas closer to the US right now are warmer than normal. Not quite as warm as last year, but the biggest difference right now is actually in areas of the Caribbean and the main development region, which is currently a little bit cooler than normal. Now, we're not anticipating these areas to stay as cool throughout the whole season as they are right now, but having cooler temperatures year on year, we think that is an important difference, and we'll talk about the details here of that in a moment. Now, turning attention to the Western Pacific and Indian Ocean areas, if we take a closer look at the SSTs there, you can see that again, it's a variable situation across areas of the Pacific, while the Indian Ocean has a bit more of a warmer flavor to it. And so overall, for the Pacific Ocean, we are seeing SSTs warmer than a year ago, which we think is going to have important ramifications here And also kind of similar to the Atlantic, there are several of these hot pockets around, these smaller scale regions of warmer than normal SSTs. You see that here off the coast of China and in around Taiwan, and then in the Bay of Bengal and Arabian Sea. Those areas of warmer waters do need to be watched here for any cyclones or typhoons that specifically track over those areas. So overall, with the setup here of SSTs, certainly some unique signals that we're seeing going into this season. So kind of having set the table for the forecast in terms of SSTs, again, that is one of the primary drivers of the pattern. There are other variables that do drive patterns. We're not going to get into the details, but with over 2/3 of the Earth covered in water and with the main tropical areas of the globe critical for storm formation, we are putting much more weight or more emphasis on those SST patterns. And so with that, putting everything together in terms of the base state of SSTs, here is our breakdown of each basin in terms of the risk and the overall main expectations in each of these basins. So of the main ocean basins, it is the Atlantic that has the highest risk, and we are anticipating another active season. The combination of warmer than normal water temperatures, more of a neutral to slightly weaker La Nina in the Eastern Pacific that still points to an above normal risk, but not quite as high as a year ago. But of all of the basins, that is the basin with the highest risk. And ultimately, supply chains and business operations in and around the basin need to be prepared for another season of above normal risk. In the Westpac, again, normally the most active basin on the globe here, we are forecasting a normal to slightly above normal risk season. And so having said that here, that is a market change year on year. As again, last year was very, very quiet across the Western Pacific, still some disruptive storms, but overall it was a very quiet season. And with the neutral to weak La Nina conditions in the Eastern Pacific and with the variable SSTs across the Westpac Basin, this points to a season that kind of returns to something closer to normal and ultimately back to a climatological normal risk of disruptive events and storms across the Westpac region. In the Indian Ocean, similar to last year, we are expecting generally close to normal activity and a normal to slightly above normal risk season. That slightly above normal risk season is really due to, again, some of the pockets of warmth in portions of the Indian Ocean, but all in all, quite similar to a year ago there. And then lastly, across the East Pac Basin, normal to slightly below normal risk is expected, again, with the bias of cooler than normal water temperatures there. That does tend to limit things, although, again, last tropical season was a developing much stronger La Nina event. And this year, with more normal or just slightly cooler SSTs, again, that points to something a little more active compared to a year ago, but still overall a normal to slightly below normal season. Now let's take a deeper dive into some of the metrics here and look first at our Atlantic ACE forecast. So again, of all of the tropical basins It is the Atlantic, which has the highest risk. And we are currently forecasting the ACE value, again, accumulated cyclone energy, that risk to be 125 to 150, as you see here on the chart to the right. So compared to normal, the normal over the long-term time frame here is 110. So we are expecting an above normal season, and which, if verified here, would be the 6th consecutive above normal season. But it does look to be at least a lower ACE value, a bit quieter compared to last year, and certainly signals pointing away from not having a hyperactive season like last year, as the state of SST is certainly limiting some of the development there across the basin. Now, as I mentioned before, in some of the regional SSTs, some of those hot pockets, again, for individual storms, need to be watched here. And as we go through the season, some of the risks that could help change this initial forecast, and we'll be providing some of these in our updates. Again, if we see any large-scale SST changes, whether that's in the Gulf of Mexico or across that MDR region, that could help to change our values here, our forecasted values, as we go through the season. But initially here, we are expecting that 125 to 150 in the Atlantic. As for the West Pacific, in terms of ACE here, again, compared to other basins, the West Pacific always has the highest number of highest value of ACE. Normal over the past 40 years is 300. We are forecasting, again, with more activity this year compared to last year. Our ACE forecast for the Westpac Basin is 275 to 325, so right near the normal range. And certainly a huge change from a year ago, which again was one of the lowest ACE values going all the way back to 1980. In fact, it was the one of the 5th lowest, and this year kind of back to normal. Certainly much more elevated risk across that zone. So next, let's go into some of the supply chain details here based on our forecast of ACE in these two critical basins. So applying our weather predictions now to supply chains and business operations around the world, again, kind of everything else being equal, the supply chain nodes and networks within the Western Pacific, those normally have the highest risk of being impacted. But as we look specifically here in the Atlantic first, with the Atlantic supply chains, again, that's where you can have a bit more significant swings in activity. And obviously last year was quite significant in terms of number of storms, obviously record setting, and overall disruptions to the supply chains. As we look at the overall industries here impacted across the Atlantic basin, so typical industries impacted, and we saw that in certain industries more so. Last year. Those industries include pharma, technology, chemical and energy, agriculture, automotive and retail. Certainly some regional focused industries here in portions of the East Coast and Gulf Coast, and then scattered around the Caribbean region. But as we look at this snapshot of our next-gen platform with the major with our major freight ports and cargo airports across the region, with the active season that we're expecting here, certainly these are some of the major hubs that need to be watched. So again, if you have any of these transportation hubs or business center hubs within your network, that there is that risk of more disruptions this season. Again, not all areas are going to be impacted, but knowing ahead of time whether these cargo airports or major freight ports are at elevated risk here compared to others. Again, the main item here is for you to be prepared going into the season that there is some elevated risk here. Obviously, all the details will be dealt with on a week-to-week basis and one month-to-month basis as we go through the season. But with the Atlantic Basin, more active conditions expected, certainly elevated risk of more disruptions in these various sectors here and at some of these ports. And again, this is all within the base state of what's already significant issues given the COVID recovery, as well as other regional issues within the zone. Lastly here, let's take a look at the West Pacific Basin, which again is normally the most active basin. And again, similar supply chain hubs impacted by tropical activity, but with the expectations of a much more active Pacific Westpac Pacific season here year over year, then these industries that we have here on the right certainly at higher risk of seeing disruptions, especially compared to last year, and kind of back to more normal risk. Now, some of the major freight ports and cargo airports within the region, last year, we saw some of the more significant activity in portions of Vietnam, and then a few storms did hit South Korea and then in Northeast China. But the bigger issue there was more on the flooding side of things. But all of the major ports and cargo airports that you see here across the region, again, more kind of normal risk expected. So again, those with networks within the zone need to be ready for a more kind of normal season in terms of risk. Lastly, do want to cover the Indian Ocean, which again, the industries are very similar to the Pacific as well as into the Atlantic. But what we want to do now is show an example of, again, how our customers use our next-gen application to navigate tropical risks as we go through the season. And so currently, there is a developing cyclone in the Indian Ocean. It has not formed yet, but conditions are becoming much more favorable for storm development. And as a result of that, over the past day, we have issued one of our watchtower alerts for the west coast of India and on into the southern portion of Pakistan. And that is at medium risk right now, certainly something to keep an eye on with the development. And so any supply chain networks on the west coast of India need to keep an eye on this system. In fact, for those with interest in and around Mumbai, this is a risk timeline of the port of Mumbai, looking at the window of highest risk of either disruptions via wind or heavy rainfall or conditions that could potentially impact the port or close the port, either for a short period or for a long period. But this is how you can utilize the risk timeline for individual nodes within the supply chain to manage the risk and make your decisions out in front of these tropical systems. And all the underlying data, whether that's for individual regions such as India or spacing that out to other areas across the globe, all of this data can easily, a few clicks here, you can find your main ports and supply chain hubs of note, and this data can be exported and analyzed as needed here. But certainly a real-time situation with a tropical cyclone that we're seeing right now in the Indian Ocean. And so stay tuned here for the development of the system. And certainly here, kind of following on the heels of the typhoon, super typhoon Surgai in the Western Pacific, that just missed the Philippines a few weeks ago. Now we're seeing the potential for some other tropical cyclone risks, and that is, for the time being, in the Indian Ocean with this developing cyclone. So with that, let me pass things over to John, as he will be discussing some very intriguing tropical trends that have significant ramifications on the global supply chain.
Great, thanks, Mark. So, in our final section today, we're going to talk about the concept of climate change and what that means for tropical cyclone activity. So, this is certainly a subject that has been hotly debated, pun very much intended. And it's kind of interesting when you look at the overall situation. In other words, you look at tropical cyclone activity globally, there's no clear evidence that the activity, the number of tropical cyclones around the globe, has been increasing over the last couple of decades. What is very interesting is that when you go into the details, and I guess kind of the devil is always in the details, there are certainly trends that have been quite evident and certainly that have been quite clear. And some of these trends then have major ramifications on the supply chain world. In our report that everyone will get later on today or tomorrow, we go over in some depth into some of these different trends here that have major implications on the supply chain. In this case, we'll just cover briefly a couple of these trends that have some of the highest risk and certainly the highest implications as to what's going to be happening here from this point on and also into the future. So, item number one is what we call the poleward shift. So, if you look at activity overall here across areas of the Northern Hemisphere, for example, there has been clear evidence that the periods where storms reach maximum intensity, that's been shifting north or poleward. It's also happened in the Southern Hemisphere as well. And the area of the greatest migration northward has been in the Northwest Pacific. Again, one of the key, if not the key areas from a supply chain standpoint on a global basis. So just as an example of this. So typically, in the West Pacific, we tend to get a lot of activity. And the map that is underlying here is all the major cargo airports and all the major ports across the West Pacific. So, what has been happening over the last couple of decades is the fact that these storms and the stronger intensity storms that has been shifting northward with time. So, for example, many decades ago, your stronger storms would have been a little bit further south across this area, northern Philippines, southeast China, Taiwan, places like that. And lately, then that shift has been more in the northward direction. Why do we care about this? Why is it important? It's because you have a higher concentration of overall ports further north and air cargo facilities across those areas. So, in other words, the risk is increasing in places like northern China, South Korea, and Japan for all their supply chain operations with this northern shift in the West Pacific of the stronger storms that have been moving into the region. We'll talk about the physical reason behind this here in just a minute, but certainly this poleward shift has been quite evident, or in this case, the northward shift here of these stronger storms across the western portion of the Pacific. Issue number two in the details: slower forward speed. So when we think about overall tropical activity, and this is true also with other storms like storms in the winter as well, there has been pretty clear evidence that overall tropical activity has been slowing down with time. In other words, if you add up all tracks on a global basis, the forward speed of all those tracks, it's a little bit slower now than what it was 2 and 3 and 4 decades ago. In other words, you tend to have more storms that tend to move slower or tend to stall out. And the chart here on the left is a look at some of the tropical cyclone movement and overall here how much of these slowdowns have occurred across the region. In the North Pacific, the area we just talked about, has the highest level of the slowdown of speeds here coming up. Why does this make a difference? Why do we care about this? Well, when you tend to slow down storms or stall out storms across areas, the level of risk or the level of damage tends to increase. So there's more duration of either higher winds in a coastal location or inland, and also, there tends to be a higher incidence of having extremely heavy rain events because of these slower moving or stalling of storms here on a global basis. So think of the last couple of years, some of the slow moving storms and the ramifications that have had. 2017, Harvey in the Houston area. 2018, Florence in the Carolinas. 2019 Dorian, especially in the Bahamas and areas of the East Coast. And last year, Sally and Ada in areas of Central America. So, this overall tendency of overall storm systems slowing down or stalling, it increases the damage rates across areas and also increases the rain rates across these locales here coming up. And again, tropical cyclones are really good at turning water vapor into rain. And if you slow down the systems, the rain rates have significantly increased over the past couple of decades. Higher risk of inland flooding, higher risk of overall damage here across these locales. Third issue, and this is something we've seen a lot of here lately, is what we call RI, or rapid intensification. So this is an image of Hurricane Laura last year in the Gulf of Mexico, moving toward Louisiana. And we've seen a higher incidence of what we call RI, or rapid intensification. Again, why is that important? It's important because most of the major storms, the ones that are the big disruptors within the supply chain, most of those go through rapid intensification. So those are the ones that have the biggest impacts in an area, and also reverberate globally, around the world from a supply chain standpoint. And we continue to see this increase in numbers of storms that go through this overall rapid intensification. Now, the definition of RI is an increase in 24 hours of winds of 35 miles per hour. We had 10 of those last year. Again, an all time record. And last November, we had two of the storms that hit Central America gain 80 miles per hour in 24 hours. There's only a handful of storms that have done that overall here in history. So, this overall pattern of rapid intensification of storms, especially near the coast, has been a trend that has been increasing over the last couple of decades. And again, this increases the overall risk out there of these stronger storms, the big impactful storms affecting supply chains, affecting communities, affecting people across areas. And this is a global phenomenon. It's not just the Gulf of Mexico or the Atlantic Basin, it's all areas around the globe. So, in talking about these three issues here and these kind of three details overall out there, the physical reason behind these and many things that we've been observing over the last couple of decades, of course, it gets into overall ocean temperatures. And if we look at overall ocean temperatures, out there, and the increase in global ocean temperatures has been a trend that we've seen for many, many decades. This is looking at global ocean temperatures, all areas, starting in 1979, going through last year, 2020, in the increase in temperatures globally in that time frame. The global oceans are getting progressively warmer with time. And basically, that means that there's that much more heat, there's that much more water vapor, and there's that much more heat content for overall storms here to use to get their energy. That really explains rapid intensification, and it certainly explains some of the poleward shift or the northward shift in areas like the West Pacific. As to warmer water temperatures, storms can maintain their strength further north across those areas. And again, of the three things that we talked about, it really comes down to global ocean temperatures and that steady increase over many, many decades of the global oceans, and also other items out there, such as items in the winter and higher humidity levels, warmer temperatures. A lot of the things we observe have a crux in this chart right here as to the global oceans warming with time. So let's wrap things up, and then we'd like to open it up for questions. And so really the takeaways for today's presentation, and there's a couple. Certainly one is that the basin with the highest risk compared to normal or compared to climatology, it's the Atlantic Basin again this year. That is the area where you have higher risk compared to normal than any other basin out there. Another takeaway is the West Pacific. Of course, the West Pacific Basin last year, had a relatively quiet year and, little disruptions here, at least for that area, which is the most active zone on the globe. This year looks much, much different. So a big change year on year from what we saw last year as to a much more active situation here this year coming up. And during the season, as we go through the next couple of months overall here, then of the things that we've observed, of the things that have physical characteristics, and we keep seeing more and more year on year, this whole tendency of stronger storms moving further north, what we call poleward, slower moving storms, storms kind of slowing down or stalling, and the ramifications there, both from a wind standpoint and also an inland rainfall standpoint, and of course, rapid intensification. As to, most of the majors go through rapid intensification, and those are the items that have the biggest impact on people, on communities, and on the global supply chain. So with that, I'll turn it back over to Dana, and I think we're going to open it up for some questions. Dana, back to you.
Thank you. That was awesome. Thank you guys so much for that valuable insight. If the audience has any questions or comments, please use the chat or the question function. Let me see if we can pull up any questions now. All right, we've got a question in here. Let's see. Is there any indication if there will be more activity in the Gulf of Mexico or the East Coast, or is there an equal risk?
Yeah, I can take that one here. Really, really good question. Um, I think a couple of different comments here is that last year, the Gulf of Mexico, and I think included in that would be the Western Caribbean, what happened in Central America, that was the zone of highest activity. We kind of call that the sweet spot, if you will. That was the zone where you had the highest number of storms rather than along the East Coast. There's no indication of that happening this year again, meaning that the Gulf of Mexico has the bulk of activity. So we would not expect as active of a year this year in the Gulf of Mexico compared to a year ago. The second part of that answer is that, well, what is the favorite area? Is it East Coast? Is it Florida? Is it Gulf Coast? Is it Central America? So much of that comes down to circumstance of individual storms, specific steering currents when individual storms tend to develop, and regional SSTs. And as we sit here on overall May 13th, there's no real skill in saying that the East Coast is going to be that much more active than, let's say, the Yucatan or the Caribbean or possibly areas along the Gulf Coast. So that is something that kind of plays out as we go through the season overall. But at this stage of the game, there's no real skill in looking at a specific area that has the highest risk and picking out a state or a county or a regional area across the US here coming up. So kind of TBD on that situation, and that's why we watch things day to day and hour to hour as we go through the season here upcoming.
Thank you. We've got another good question here. I think it was Mark, you were talking about the drivers. So this question would be for you. Is there a poleward trend in the US East Coast moving towards the port of New York, New Jersey, and maybe even Norfolk?
Yeah, with again, more on the with the current SSTs being warmer than normal, certainly something to keep an eye on. That doesn't necessarily mean that storms this season are going to track more in that northward direction, but the fact that the SSTs are there, if there are any storms that do take that path up the East Coast or towards the Northeast or New England or Southeast Canada, then those warmer SSTs, if they hang on, which will likely be the case, it would be tough to change those SSTs between now and let's say October 1st. But any storms that move through would have more energy to work with to either stay stronger further up north or just be a stronger storm. Now, what John mentioned in the climate change section is that of the poleward movement of storms, just looking across the northern hemisphere, the Western Pacific, that's where the signal is the strongest over the past several decades. It really hasn't been off the west coast or off the east coast of the U.S. So it's not like all the storms moving in that northward direction or staying strong further north there. But for this particular season, the fact that those warm SSTs are in place, that at least does lean in the direction that storms a bit stronger as they move poleward and move northward across the region.
Thank you, Mark. Got another question in here. Let's see. Can you give a perspective on the disruption, magnitude, and duration due to the major storms? For example, delays to entering a port or infrastructures being damaged for long periods. Can you give a perspective on the disruption, magnitude, and duration due to the major storms?
Yeah. Again, now I think we're talking about, the upcoming season here, and the forecast of that, I assume. And again, that the kind of answer is very similar to the answer about, location. Um, Again, we know that there's higher risk here overall across the Atlantic Basin going through this year. We also know that the West Pacific is going to be much different than a year ago. But the details of that, what ports tend to have the highest level of disruptions, what overall air cargo centers tend to have the longest, duration of issues here coming up, and the biggest disruptions out there. Again, that comes down to the details and the specifics. And a good example of that is what happened last year. So you had a myriad of storms hitting into western Louisiana. It just so happened that that was a favorable track of a lot of storms here last year. If you would have had those storms move, a little bit further east into the New Orleans area, or a little bit further west into the port of Houston and Galveston, that would have been a much different situation and caused disruptions for weeks, if not months, across those regions. So because the storms basically were moving into western Louisiana, you had more minor disruptions in those areas compared to like a direct hit on Houston or New Orleans here that would have caused extremely long period of disruptions. So again, in looking at things here down the road, that comes down to the details, the specifics of what individual storms do in the Atlantic and in the Westpac and also other areas around the globe.
And that's another reason why it just pays to be prepared, because I mean all it takes is just $1 billion storm and that's it. So and also if you guys have, I'm talking to the audience now, but if you guys have specific questions about your particular operating network, please be sure to go to our website everstream.ai. and see if you could, if you want to schedule a call with John or Mark to look at your network and see what the options and possibilities are, so that you guys can be better prepared for what's coming up ahead. All right, let's take one more question here. Let's see. Let's see. We do have, let's see. Every year, the hurricane season officially begins on June 1st. This one would be for Mark. However, last year it had an early start, and just like last week, we had the earliest named storm, Tropical Storm Andres, in I guess, the East Pacific Basin. Do you see a pattern in that tropical storm season might start earlier every year? Do you see this continuing in a trend?
Really interesting question there, and I guess the short answer is yes. The season overall is being extended on at the front end of the season, and then extended at the back end as well. And that is due to the warming of SSTs. So with those warmer SSTs in place, again, given the right atmospheric setup, you can develop storms earlier than normal. So while we haven't seen our yet in the Atlantic basin, yeah, we've seen the first named storm and the earliest on record for the East Pac with Tropical Storm Andres that developed this past weekend. And some of the actually some of the cooler temperatures here that we've seen in the US and portions of Europe, that has actually helped to create higher wind shear across the Atlantic basin. So even with some of the warmer SSTs right now, the atmospheric conditions haven't been all that favorable, at least earlier than normal. But again, over time, as long as SSTs continue to warm, and our thought is that the trend is in place until it reverses, or until it's no longer there, then over time, then yeah, that should lead to a continuation of an earlier season, in general across the global tropics, and also a later season as well, extending things into November or even beyond as well.
Oh, goodness. All right. Thank you. We got one more question. Actually, we have a couple more. All right. Let me just take this one. What number of hurricanes do you expect this season? Dun, dun, dun.
We specifically forecast ACE, kind of overall. If we kind of relay ACE to, we think that's a better way of an overall measurement. However, if we specifically relate, that to the number of hurricanes here this year, basis kind of where our ACE is at. And I assume the question is for the Atlantic Basin, but numbers of hurricanes here this year would tend to be in the level of 10-ish, 9 or 10-ish here for this year. So not as active as last year. Last year was 14 in 2020, but 10 certainly would be, a relatively high year, climatically, but not to the level of a year ago.
Awesome. I know I keep saying last question, but seriously, there's just really good questions coming in right now. So I really appreciate you guys typing in these questions. We got one from Lawrence. Thank you, Lawrence. Given the increase in technology, are you hopeful that we will be able to predict the likelihood of rapid intensification storms a little earlier?
Awesome question.
Thank you.
And technology has advanced here, obviously in many different ways, but specifically with tropical cyclones, technology has advanced quite a bit just in the past 4 to 5 years. And so just comparing now to, let's say, 4 or 5 years ago, in that period of rapid intensification and forecasting that earlier than normal, that has improved in recent years. It can continue to get better, and I think it will get better as technology continues to advance. technology in the form of, again, better or faster, stronger supercomputers that's cranking away at all the weather data that and ocean data that goes into them. But then also just in terms of observation data, now we have drones. Drones not only helping with supply chain advancement, but actually from an observation standpoint, there's more and more drones being used for sampling weather, and all that data goes into the supercomputers to help meteorologists with forecasting the upcoming strength and track of storms. And so, it's going to continue to improve, and more can be done here, but it's certainly exciting. And this is the weather nerd here, pardon me talking here, but it's exciting times to see the advancement in technology and getting to the point where, with rapid intensification, knowing days in advance versus hours in advance that could take place, helping to provide more accuracy.
Awesome. Well, I appreciate everyone's questions, and thank you, John and Mark, for your wonderful insights as usual. It's time to wrap up today's webinar. On behalf of Everstream Analytics, we'd like to thank everyone for their time. And if you are interested in a little bit more detail, we will be launching our Tropical Storm Season Outlook Report today. So look for that email in your inboxes, and we'll also be sending out a recording of this webinar as well. So in case you want to listen to it again on demand or share it with a friend, please do so. We hope you guys enjoyed the time, and we will talk to you soon. And if you guys have any questions or would like to speak with John and Mark, please go to our website, everstream.ai, and contact us. Thank you so much for your time. Have a good day.